Hello, in this discussion we're going to be solving applied problems using the law of sines again. So let's begin with this example. To measure the height of a mountain, a surveyor takes two sightings of the peak at a distance 900 meters apart on a direct line to the mountain. See the diagram here. Alrighty. The first observation results in an angle of elevation of 47 degrees, and the second one results in the elevation of 35 degrees. If the transit is 2 meters high, what is the height of h of the mountain? All right, let's look at this. So they draw you a little picture. All right, so they are that far apart. They are 900 meters apart. The first angle is 35 degrees. The next one is 47 degrees. So they draw you a two-dimensional scale here. So C plus 47 degrees is 180 degrees. Alrighty. Which makes C 133 degrees. So looking at that picture, that's 133 degrees. Alrighty. A plus C plus 35 degrees is 180 degrees. So we're basically trying to find the angles of the smaller obtuse triangle. So angle A is 12 degrees. So what we're going to try to do is find some unknowns on that triangle right there. Alrighty. So sine of 12 degrees over 900, that's how far the transits are apart, equals a sine of 133 degrees, which I just found a while ago, and this is over C. So that's going to give me that longest side on the left by cross multiplying and then dividing by the sine of 12 degrees, and you get 3,165 meters, 0.86 meters, I believe. So C is that. So from that outer edge to the peak is 3,165.86. I believe it's meters. Yeah, it is meters. So 3,165.86 meters. All right, from that outermost point to the top of the peak. Now sine of 35 degrees. Now this is just a right triangle here. Is B over C. That's the reason we figured out what the B was. So, the C, that's why we figured out what the C was a while ago. So B is 3,165.86 times the sine of 35 degrees, which is 1,815.86 meters. Okay? Alrighty. So that's approximately what we have here. All right, so I believe that finishes up this one. And then we'll look at another example here. We're going to look at a Coast Guard station. Zulu is located 120 miles due west of Station X-Ray. A ship at sea level, or at sea, sends an SOS call that is received by each station. The call to Station Zulu indicated that the bearing of the ship from Zulu is north 40 degrees west. That's 40 degrees, north 40 degrees east. That's 40 degrees east of north. The call to Station X-Ray indicates that the bearing of the ship from X-Ray is north 30 degrees west. That's 30 degrees west of the north. Remember our discussion about bearings in a previous discussion. So how far is each station from the ship? So let's look at the diagram. Now angle C, the one right below the ship there, is going to be 180 minus 50 minus 60 degrees, which is 7 degrees. So remember, these east to west, those angles are 50 degrees because that one bearing is north 40 degrees east, and the other one was going to be what? North 30 degrees west, which makes the other angle 60 degrees. And so that makes the angle at the top 70 degrees. And then it's just a matter of the law of sines. The sine of 50 degrees over A, which we don't know that one, equals the sine of 70 degrees over the distance the two stations are apart, which is 120 miles. And that makes it 97.82 miles from A right there. So A is the one on the right. So that's how far the station that's on the right is. Now we do the same thing with the other station. Sine of 6 degrees over B equals sine of 7 degrees over 120. So it's a very similar setup. You worked exactly the same way, cross multiplying. B, which is the station that's on the left there, it's 110.59 miles. Now what was the other one? The other one was 97.82 miles. This one is 110 miles. So that was a little farther away. So Station Zulu is about 111 miles from the ship, and Station X-Ray is about 98 miles from the ship. So X-Ray is a little closer. Now, the time T needed for the helicopter to reach the ship from Station X-Ray is found to be the formula rate times the time equals distance. That's distance equals rate times time. All righty? So they're 111 miles apart. Oh, sorry, that one's 98 miles apart. Divide that by 200 because that's how fast the helicopter is flying. So 97.82 divided by the rate, which is 200, which is 0.49 hours, or just under a half an hour. So if he leaves Station X-Ray to get to the ship, it takes like 29 minutes to get there. So, but I want you to look at the picture very closely here, and that kind of tells you, how to do it. So drawing the picture on these problems is probably the most complicated part of this. So it would take about 29 minutes for the helicopter to reach the ship if he flies out of there. All righty? Now let's look at the law of sines. We've used it a few times. Let's prove it. Well, if you look at a triangle that looks like that, either way you look at it, it's going to be H equals, the height of the triangle is C times the sine of angle A. Okay, if you're looking at the left one, because the sine of angle A is H over C, so H is equals to C times the sine of angle A. But on the other hand, if you do sine of angle C, that's H over A. So solving for H, you get H equals A times the sine of angle C. Now the height of the triangle does not change. So they're going to be the same in either case. So that means C times the sine of angle A is going to be the same as A times the sine of angle C. Now if you divide both of those equation by AC, the numbers out front, you get sine of angle A over little a equals the sine of angle C over little c. So that's the proof of the first of the three. Now you can prove the second of the three by drawing a different height using a different part of the triangle. But it works the same no matter which way you slice it. You could use this side as B's instead of the C's and get those the same. So pretty simple proof on the law of sines. So what the purpose of the law of sines again is going to be finding the unknown parts of a triangle that's not a right triangle, okay, and it gives you a formula to do that with, okay. So before this course, if you want to know the unknown parts of a triangle, the only thing you knew was the Pythagorean theorem, or if you know a little bit about trig, SOHCAHTOA. So this gives you the ability to find the unknown parts of any triangle, not just a right triangle. All righty? So if you have any questions about this discussion, you let me know, and you have a good day.